Address and pointers are considered as tough to understand. But in my view, it's the most simplest part to learn in C language. Address and pointers are the heart of C programming. An embedded C programmer should understand this topic clearly. Let's understand what is an address. Everything in real life has some location. For example, we keep our bathing soap inside soap case. Soap case is kept in a cupboard. This cupboard has to be in bathroom. Other example could be railways are put to rest in a rail yard, or more day-to-day example could be that pizza is served in a plate. Imagine if in all above examples, we change the location of the items such as bathing soap inside a microwave oven, or railways are put to rest on the road, or pizza is served in a teapot. This will make our life impossible. Understand that for our real-life examples, we find places to keep our items somewhere in a restricted area like our home, our city, or this world. Similarly, in C programming or any software program including the embedded application, each variable used has a location. These locations are available on a RAM. RAM stands for Random Access Memory. Your PC has a RAM. Similarly, any embedded microcontroller has a volatile memory area, where the values will be located. In the picture shown on your screen, the green area represents a RAM of PC or of microcontroller. This RAM is divided into thousands of small areas. This area is called as a byte. As each house in your city has an address, similarly each byte on this RAM has an address. This address is specified as the byte number. This address numbering starts with 0. Thus the first byte on a RAM will have address location 0. So on each byte will have incrementing addresses. Now if you are wondering as what a byte means, the answer is simple. Byte is a collection of 8 bits. Individual bit can store binary value 0 or 1. In simple words, if you declare a variable named temperature and assign a value 45 to it, this is what happens on a RAM. The green block shown on your screen represents a byte. This byte is located at address 23 on a RAM. This memory area holds a value 45. Now we know that address indicates location in a memory and value indicates contents of the memory location. Here we can say that address of variable named temperature is 23 and value of variable temperature is 45. Remember that we can specify address of a variable in any numbering system. As I said, address of variable named temperature is 23. I assumed a decimal numbering system. Same address can be expressed in hexadecimal numbering system as 0x17. Use Windows calculator to convert decimal 23 to hex value. Generally addresses of memory are specified in hex format and values of memory are specified in decimal format. But this should not be the rule in any case provided you indicate the number system you have used to specify the same. Let me explain concept of pointers using a problem statement. Assume that I have declared a variable named marks of type int. I have assigned value 82 to the marks variable. Can you tell me the address of variable 82? Can you store the address of variable marks to some other variable? Answer to both questions is written on your screen in blue color text. Remember that we require pointers to store address of a variable. Hence we have declared a pointer type variable. To declare a pointer type variable, you have to add a star symbol before the name of variable. On the 4th line of the code, address of variable marks is assigned to pointer variable ptr. Address of any variable can be retrieved by adding a ampersand symbol before name of variable. This is also called as ptr now points to marks. Let's understand the contents of variable marks and ptr. Variable marks contents value 82. Pointer variable ptr contents address of the variable marks. We as a programmer have no control over assigning addresses. A particular variable address location will be assigned by the operating system of your PC. But in embedded development, in most of the cases a programmer can specify as where to store the temporary values inside the microcontroller RAM. Marks1 is a variable of type integer. The 5th line demonstrates to use pointer to retrieve the value of variable, to which it is pointing to. To do this, add a star symbol before the pointer variable and assign it to the simple variable to store the value. Thus now marks1 will hold value 82. Always remember that you should keep the data type of a variable and that of pointer variable same. That the reason we have declared marks and ptr of